Welcome. In this video, I'll be showing how to use the standard normal tables to calculate probabilities in a normal distribution. A normal distribution is a symmetric, bell-shaped distribution where the area under the normal curve is 1 or 100%. The standard normal distribution, or what is also called the Z distribution, is a special normal distribution with a mean mu of 0 and a standard deviation sigma of 1. The formula for transforming a score or observation x from any normal distribution to the standard normal score is z equals x minus mu over sigma. The standard normal score, also known as the z-score or z-value, is the number of standard deviations a score x is from the mean. The standard normal tables we will be using are the less than cumulative tables. They usually have the left tail of the distribution shaded and also have positive and negative parts. Let's look at an example. Scores on an exam are normally distributed with a mean of 65 and a standard deviation of 9. We want to find the percent of scores satisfying A, B, and C here. In A, we want the probability that x is less than 54. So for x equals 54, the corresponding z-score is 54 minus 65 divided by 9, and that gives negative 1.2222 repeating. Since the z-table is set up to handle only 2 decimal places, we round this to negative 1.22. We then go to the z-table and look up the area. For z equals negative 1.22, we go to the negative side of the table. Look for negative 1.2 in the first column and 0.02 at the top. The corresponding area here is 0.1112. That is, the area to the left of z equals negative 1.22 is 0.1112. So on this normal curve, for z equals negative 1.22, the area on the left here is 0.1112 as seen on the table. Therefore, the probability that x is less than 54 is the probability that z is less than negative 1.22, which gives 0.1112 or 11.12%. In B, we want the probability that x is at least 80. In continuous distributions, like the normal distribution, there is no distinction between x is at least 80 and x is greater than 80. We apply the same approach in both cases. So for x equals 80, z equals 80 minus 65 divided by 9, and that gives 1.67 to 2 decimal places. When we look that up in the z-table by checking 1.6 under 0.07, we find 0.9525, which is the area to the left of z here. We then subtract it from 1 to obtain the greater than area, since the total area under the curve is 1. Therefore, the probability that x is at least 80 is the probability that z is greater than 1.67, which equals 1 minus 0.9525, giving 0.0475 or 4.75%. In C, we want the probability that x is between 70 and 86. For x equals 70, z equals 0.56. And for x equals 86, z equals 2.33. On the table, the area less than z equals 2.33 is 0.9901, while the area less than z equals 0.56 is 0.7123. When finding the area between two z values from the cumulative less than tables, we subtract the smaller area from the larger one. So the probability that x is between 70 and 86 is the probability that z is between 0.56 and 2.33. That is 0.9901 minus 0.7123, which gives 0.2778 or 27.78%. In summary, if you're finding a less than area using the cumulative less than tables, the area in the table is the answer. If you want a greater than area, then do 1 minus the area from the table. And if you want the area between two z values, then do bigger area, which will correspond to the larger z value, minus the smaller area, which will correspond to the smaller z value. Note that we do not subtract z values, we only subtract areas. And that concludes this video. Thanks for watching.